The water is wrong. 370 million years ago, in what will one day become Cleveland, Ohio, the ocean shimmers with a poisonous green luminescence. The temperature hovers at a tropical 90 degrees. There is no ice anywhere on Earth. Carbon dioxide chokes the atmosphere at levels 4,000 parts per million, 10 times what you breathe today. This is not your ocean. This is the Devonian. Beneath the surface, in waters so warm they feel like blood, something moves through the murk. It doesn't swim like the sleek predators you know. It doesn't need to. The creature is 11 feet of living armor, a nightmare forged from bone and driven by hunger. Its head alone weighs as much as a grown man, encased in plates of dermal bone 2 inches thick. When it opens its mouth, the ocean itself seems to recoil. This is Dunkleosteus Torelli, the first true king of the vertebrate world. And right now, it's hunting. A shadow flickers in the distance. A 6-foot Cladocellaceae shark, streamlined and fast, one of the ocean's newest designs. The shark doesn't see the armored fish, not yet. In 20 milliseconds, faster than you can blink, the predator's jaws will explode open, creating a vacuum that pulls the shark toward its doom. And when those jaws snap shut, they will do so with a force of 80,000 pounds per square inch at the fang tips. Enough to shear through bone. Enough to bite a shark in half. Welcome to the age of fishes, where the apex predator had no teeth at all. To understand Dunkleosteus, you must first understand its world. A world so alien, it might as well be another planet. The late Devonian period, spanning from 382 to 358 million years ago, was an epoch of extremes. North America sat near the equator, rotated 90 degrees from its current position. What is now Cleveland, Ohio, lay at 23 degrees south latitude, tropical, sultry, perpetually warm. The continents were still assembling themselves. Gondwana dominated the southern hemisphere, a supercontinent stitching together South America, Africa, Antarctica, India, and Australia. To the north, Euramerica, the fusion of Europe and North America, collided with fragments of ancient land masses, thrusting up the ancestral Appalachian Mountains. Sea levels were extraordinarily high. Much of the continental landmass drowned beneath shallow, sun-drenched seas. These waters were not the deep blue of today's oceans, but milky and mineral-rich, teeming with suspended sediment from the erosion of newborn mountains. The climate was a greenhouse nightmare. With no polar ice caps and atmospheric carbon dioxide levels between 2,000 and 4,000 parts per million, Earth baked under a thick atmospheric blanket. Temperatures remained uniformly warm from pole to equator. There were no seasons as we understand them, only the endless, humid constancy of a planet-wide sauna. But the Devonian was not merely hot, it was transformative. On land, the first forests were rising, towering Archaeopteris trees with true wood, their roots breaking rock and creating the world's first soil. Insects scuttled through the leaf litter. The first tetrapods, creatures with 4 limbs, were pulling themselves onto muddy shores, gasping air for the first time. Life was leaving the water. But in the water, life had reached an unprecedented crescendo. The Devonian earned its nickname, the Age of Fishes, through sheer abundance and diversity. Armored placoderms ruled the seas, their bony plates glinting in the filtered sunlight. Primitive sharks like Cladocellaceae cut through the water with torpedo-shaped bodies, still experimenting with the design that would eventually make them the ocean's most enduring predators. Ray-finned fishes, lobe-finned fishes, jawless fishes, all filled ecological niches we can barely imagine. and coral reefs stretched across the shallow seas. Massive structures that would not be rivaled again until the Mesozoic era, some 150 million years later. This was the world Dunkleosteus inherited. A world of plenty, a world of prey, a world waiting for a predator terrible enough to dominate it. In 1867, a hotel owner named J. Terrell walked along the cliffs near Sheffield Lake, Ohio, on the shores of Lake Erie. Embedded in the black shale, the compressed remnants of that ancient Devonian seabed, he found something extraordinary. Massive plates of bone, interlocking like medieval armor, belonging to a creature unlike anything alive. He had discovered the first fragments of Dunkleosteus terrelli, though it would be nearly 90 years before the creature received its proper name. The name itself is a tribute, Dunkle's bone, honoring Dr. David Dunkle, who spent decades studying these fossils at the Cleveland Museum of Natural History. And what the fossils revealed was magnificent and terrible in equal measure. Dunkleosteus terrelli belonged to the placoderms, the armored fishes, specifically to a group called arthrodires, meaning jointed neck. Recent studies have refined our understanding of its size. For decades, paleontologists envisioned a monster 30 feet long, rivaling modern orcas. But careful analysis of head proportions and comparisons with complete skeletons of smaller relatives suggests something different. Most adult Dunkleosteus measured around 11 feet in length, with exceptional individuals reaching perhaps 13 feet. This revision has led some colleagues to affectionately dub it Chunky Dunk, because while shorter than previously thought, this fish was built like a wrecking ball. An 11-foot Dunkleosteus weighed roughly as much as a 15-foot great white shark, its body deep and powerful, more tuna than eel. The armor was its defining feature. Thick dermal bone plates covered its head and the front half of its body, interlocking with precise biomechanical engineering. The nuchal plate at the back of the skull could be over 2 inches thick, dense enough to stop almost any attack. The rest of the armor ranged from 1/3 of an inch to an inch thick, providing protection without completely sacrificing mobility. These plates weren't simple shields. They contained both a hard cortical layer and a marrow-filled cancellous layer, more similar to mammal bones than to the scales of most fish. This gave them strength and slight flexibility, armor that could absorb impact rather than simply shatter. But the true weapon was the mouth. Dunkleosteus had no teeth. Instead, it possessed something far more sinister: self-sharpening bony blades. 2 pairs of these blades, extensions of the jaw plates themselves, protruded from the upper and lower jaws, forming a guillotine-like apparatus. Every time Dunkleosteus opened and closed its mouth, the blades scraped against each other, maintaining razor-sharp edges. As the fish aged, its jaw morphology changed. Juveniles had shorter, more delicate fangs, suited for soft-bodied prey like small fish and primitive sharks. But as they matured, the anterior fangs elongated and thickened, transforming them into bone crushers capable of tackling armored prey, other placoderms, thick-shelled ammonites, anything that dared share the reef. The biomechanics of the skull were revolutionary. Dunkleosteus possessed a 4-bar linkage mechanism, a series of 4 rotational joints connecting the skull, the thoracic shield, the lower jaw, and the jaw muscles. This system allowed for something extraordinary. The fish could open its jaws in just 20 milliseconds, 1/50th of a second. The rapid opening created a powerful suction force, pulling prey toward the mouth before the jaws could snap shut. And when they did close, biomechanical models estimate a bite force of over 4,400 newtons at the jaw tip, nearly 11,000 pounds of force. At the fang tips, where that force concentrated into a smaller area, the pressure reached 80,000 pounds per square inch. This rivals the bite of large alligators and even approaches estimates for Tyrannosaurus rex. Think about that. This fish, this armored, toothless fish living 370 million years ago, could bite with a force comparable to the most famous predator in history. But Dunkleosteus was more than raw power. Fossilized stomach contents and regurgitated boluses tell us about its diet and behavior. It ate sharks, specifically fast-swimming pelagic sharks like Orodus, whose teeth have been found associated with Dunkleosteus remains. This was no sluggish ambush predator. Despite its heavy armor, Dunkleosteus was fast enough to catch some of the quickest fish in the Devonian seas. It ate other placoderms too. One specimen bears tooth marks from another Dunkleosteus, proof that cannibalism was not beneath this apex predator. When you are the biggest, baddest creature in the ocean, even your own species is on the menu. And it frequently regurgitated bones. Rather than digesting the hard parts of its prey, Dunkleosteus would swallow fish whole, extract the nutrients from the soft tissue, then vomit up the skeletal remains in compressed boluses. These fossilized pellets litter the Cleveland Shale, silent testimony to meals consumed hundreds of millions of years ago. Picture the hunt. The Devonian Sea near present-day Cleveland shimmers in the late afternoon light, filtered through 30 feet of warm, murky water. The reef is alive. Tabulate corals branching like antlers, rugose corals building their calcium carbonate fortresses, crinoids swaying on stalks like alien flowers. Trilobites scuttle across the mud. Ammonites jet backward on pulses of water. A Cladocellaceae shark, 6 feet of streamlined muscle and cartilage, patrols the reef edge, hunting for smaller fish. The shark has 5 gill slits, a deeply forked tail, and eyes positioned forward for binocular vision. It is one of the ocean's most sophisticated designs, fast, agile, efficient. But it is also young in evolutionary terms. Sharks have only recently begun to diversify, their cartilaginous skeletons and replaceable teeth still experimental features. This Cladocellaceae doesn't know it's being watched. From deeper water, Dunkleosteus approaches. Its movement is deliberate, almost leisurely. The massive armored head sways slightly with each undulation of its body. Recent reconstructions suggest a more compact build than previously imagined, broad and deep-bodied, with a tail that provided powerful thrust. The fish is not graceful. It doesn't need to be. The shark turns. Perhaps it senses something, a pressure wave, a shadow, some ancient instinct screaming danger. It begins to swim, accelerating with powerful sweeps of its crescent tail. But it's too late. Dunkleosteus explodes forward. The 4-bar linkage mechanism in its skull activates with mechanical precision. The jaw drops. The head tilts back. In 20 milliseconds, faster than human perception, the mouth gapes to a 45-degree angle. A vacuum forms in front of the jaws, pulling water and everything in it toward the opening. The Cladocellaceae feels itself yanked backward, its forward momentum arrested by an invisible hand. The jaws close. 80,000 pounds per square inch focused onto fang tips sharper than surgical steel. The sound, if there were anyone to hear it, would be like a branch snapping. The shark is bitten cleanly in two. The rear half continues swimming for a moment, motor nerves firing uselessly, before drifting toward the bottom. The front half disappears into Dunkleosteus's maw. The armored fish doesn't chew. It swallows the pieces whole, its muscular throat working the flesh downward. Later, perhaps hours from now, it will regurgitate the bones and cartilage, compressed into a pellet of indigestible remains. But for now, it simply hovers in the water, satiated, the undisputed master of its domain. All across the Devonian seas, this scene plays out. Dunkleosteus and its relatives dominate the food web from North America to Europe to Morocco. They are the first vertebrates to truly occupy the role of apex predator. The first fish to sit atop a complex ecosystem, controlling prey populations through pure predatory power. For 24 million years, the placoderms rule. For 24 million years, nothing challenges them. But empires, even in the ocean, do not last forever. Around 375 million years ago, the first cracks appeared. The Kellwasser event, named for a valley in Germany where the geological evidence was first discovered, struck during the boundary between the Frasnian and Famennian stages of the late Devonian. It manifested as two closely spaced pulses of extinction, marked in the rock record by thin layers of black shale. These shales tell a story of oceanic anoxia, oxygen levels in the water plummeting, marine life suffocating en masse. The great coral reefs that had dominated the Devonian, built by stromatoporoid sponges and rugose and tabulate corals, collapsed. They would not return to such grandeur for another 100 million years. The placoderms survived, but they were wounded. Diversity declined. Some families vanished. Dunkleosteus persisted, but the world around it was changing. The cause remains debated. The first forests on land were growing taller, more extensive. Their roots broke down rock, releasing minerals that washed into the ocean. These nutrients fueled massive algal blooms. When the algae died and sank, aerobic bacteria consumed them, depleting the oxygen in deeper waters. Anoxia spread. At the same time, those forests were pulling carbon dioxide from the atmosphere in unprecedented quantities, storing it in wood and soil. CO2 levels began to drop from 4,000 parts per million toward 400. The greenhouse began to cool. Glaciers formed in the southern regions of Gondwana. Sea levels fluctuated wildly. For species adapted to warm, stable, oxygen-rich waters, it was catastrophic. Then came the Hindenburg event. 358.9 million years ago, at the very end of the Devonian period, Earth experienced another massive environmental upheaval. This one was worse. The Hindenburg event lasted perhaps 100,000 to several 100,000 years, a geological eye blink. Black shales mark its passage once again. Anoxia, cooling, glaciation, sea level collapse, and rapid transgression. Terrestrial ecosystems collapsed as forests died back. In the oceans, the carnage was absolute. 70 to 80% of all species on Earth went extinct. All placoderms, every single species, including Dunkleosteus, vanished. The agnathans, the jawless fishes that had survived for hundreds of millions of years, were nearly wiped out. Even land-dwelling tetrapods suffered massive losses. The Hindenburg event was comparable in severity to the extinction that killed the dinosaurs, though it receives far less attention in popular consciousness. Why did Dunkleosteus die while sharks survived? The answer may lie in specialization. Dunkleosteus, with its heavy armor and specific ecological requirements, was adapted for a particular world: warm, shallow, oxygen-rich seas with abundant armored prey. When that world changed rapidly, there was no time to adapt. The armor that had been an advantage became a liability, requiring more oxygen to support its metabolic needs in an oxygen-depleted ocean. Its breeding strategy, possibly live birth with significant parental investment, as evidenced in related placoderms, meant fewer offspring and slower reproductive rates. Sharks, by contrast, were generalists. Their cartilaginous skeletons required less calcium, less energy to maintain. They could tolerate lower oxygen levels. They reproduced more rapidly, adapting faster to changing conditions. When the placoderms fell, sharks and bony fishes diversified to fill the vacant niches. Within a few million years, the modern marine ecosystem began to take shape, a hierarchy of predators that, in broad strokes, resembles what we see today. But Dunkleosteus left a legacy. It proved that vertebrates could dominate ecosystems. It demonstrated that jaws, even without teeth, could confer overwhelming predatory advantage. It showed that armor and offense were not mutually exclusive. Every apex predator that followed, from Megalodon to the great white shark to the orca, owes a conceptual debt to Dunkleosteus. It was the prototype, the proof of concept, the first king. In the Cleveland Museum of Natural History, you can stand before the reconstructed skull of Dunkleosteus torelli. The fossil is nearly complete, interlocking plates of bone compressed by 360 million years of geological time, then painstakingly excavated from the black shale of the Cleveland Formation. The plates still fit together with uncanny precision. The fang tips still look sharp. It's easy to imagine this creature alive, easy to picture those jaws snapping shut in the murk of a Devonian sea, the impact sending shockwaves through the water. But what strikes you, standing there, is the silence, the absolute, profound silence of deep time. Dunkleosteus lived for 24 million years. 24 million years of hunting, breeding, dying, evolving. Our entire species, Homo sapiens, has existed for perhaps 300,000 years. We are a footnote in comparison, a momentary flicker. And yet Dunkleosteus, for all its dominance, is gone. Not diminished, not reduced, gone. No descendants, no evolutionary lineage. The placoderms represent a dead end, a branch of the tree of life that simply terminated. But perhaps that's not quite true, because in a sense, Dunkleosteus never entirely left. When you watch a great white shark cruise past a reef, when you see a barracuda strike with impossible speed, when you witness any apex predator exert its will upon an ecosystem, you are seeing Dunkleosteus's ghost. The template it established, powerful jaws, ambush tactics, niche dominance, persists. Evolution iterates, refines, but the fundamental patterns repeat. The Devonian seas are gone. The warm, anoxic waters, the sprawling reefs, the armored fishes, all vanished. Cleveland, Ohio is now a city of bridges and lake-effect snow, about as far from a tropical sea as you can imagine. But in the shale beneath the suburbs, in the bluffs along Lake Erie, the bones remain, waiting, reminding us that this planet has hosted countless worlds, each one stranger than the last, each one filled with creatures perfectly adapted to conditions that no longer exist. Dunkleosteus torelli, the armored fish that hunted sharks, the first king of the vertebrate ocean, is gone. But its story remains, written in stone, patient and eternal. And as long as there are curious minds to read that story, to stand before those ancient bones and wonder what it felt like to rule the world, Dunkleosteus, in some small way, still lives. The ocean remembers, the fossils remain, and time, as always, continues its slow, relentless work.